So this is unit 4.3, soil composition and properties. If you're checking out this pretty cool landslide here, it may look small, but when you notice it's covering a road and there's a person on the lower left corner of that, you can see how big this landslide really is. And the fact that it happened depends on the properties of the soil where it is. If you think you like landslides, then you should definitely take a geology class. So the properties of soils are determined by several factors. The material that it's weathered from, or the parent material, what climate the soil is in, the topography of where the soil is located, any organisms that live in, around, or above the soil, and then finally time determines properties of soil. So let's start with the parent material. So material that has a lot of quartz, think the Atlantic coast like we live in, tends to be nutrient poor. So there are farms out here on the East Coast, but they're not nearly as productive as farms in other places in the US. If you have a lot of calcium carbonate, like limestone kind of thing, that can result in high calcium, high pH, and overall high agricultural productivity. So climate can affect soil. If it's too cold, then a lot of organic material goes undecomposed, and so it just sits on top of the soil and never gets incorporated in the soil. If you get places that are very warm and humid, in fact, there's rapid weathering, rapid leaching of nutrients, high decomposition, but then uptake of nutrients from organic detritus. So if it's too cold, there's not enough organics. If it's really warm, the organics decompose quickly, but then the nutrients are taken up again quickly. Topography can affect soil, slope of the soil, which is, how steep it is, and the arrangement on the landscape. So that affects the amount of erosion, right? If it's steeper, it will erode faster, and that may affect the depth of the soil also. The organisms that live in and around the soil, plants can remove nutrients from soil, right? And they use it for themselves, and they may excrete acids as well. Animals will tunnel and burrow, so things like earthworms and gophers. And then all organisms are involved in cycling of nutrients, where organisms decompose, and then those nutrients can go into the soil. And then finally, humans. Humans are really good at doing things to soil, usually detrimental things, but occasionally they can create soil as well. We'll kind of see that in the movie that we're going to watch for agriculture. Finally, time. Time has a lot of the same effects as the other properties of soil. So how much weathering happens, how much plants happen, all these things need time, and so more time tends to lead to more soil formation. Like I was saying, humans are good at degrading soil. So every time you plow the soil, that degrades it a little bit, increases the chance for erosion. The soil dries out. It can be carried away by wind. So that will degrade the soil. Soil can become compacted. Soil needs, a good mixture of air and water and minerals and organics for it to be good. So every time a machine drives over the soil, that pushes some of the air out. Humans and livestock will trample soil. If the soil gets too dry, then the water won't circulate. If the soil gets too wet, then the oxygen won't circulate. And the more compact it is, then the more resistant it is to root development, and it's harder for plants to really dig in there. If there's not enough vegetation, then erosion will increase. And so here's a good question. Is this a positive or a negative feedback loop? Well, if you take a look at the spiral on the right, you'll have decreasing vegetation leads to erosion and nutrient loss. And with fewer nutrients, there's less vegetation. With less vegetation, there's more erosion. So This is what we consider a positive feedback loop. And that positive is not a value judgment. Positive is whether the feedback loop causes itself to continue or increase. So the lack of vegetation leads to erosion, which causes lack of vegetation, which leads to more erosion. And so the feedback loop continues. In traditional agriculture, soil nutrients tend to be depleted. So for a long time, farmers would plant the same crops in the same plant every year, and they always took out like the same minerals. So if you plant the same vegetables all the time, you'll remove the sodium, potassium, magnesium, and so forth. So one way to get around this is to plant different crops on the same fields, depending on which crops take away which nutrients, and even which crops might even add nutrients to the soil. One way soil can become polluted is from pesticides, so that will degrade soil as well. And overall in the world, we can see a fair amount of soil degradation where places that humans live pretty commonly, there's a fair amount of soil degradation. Stable soil is where there aren't as many humans. And then, of course, there are places like the Sahara Desert, the Gobi Desert, where there's really just no vegetation either, usually because of climate or biome. So some physical properties of soil, the size and weight of particles. So we're going to look at sand, silt, and clay primarily, where sand is larger than silt, which is larger than clay. And we're going to do a soil test using a mason jar. When we do it, it'll look something like this. This will be a good reference to come back to be able to tell the difference between the clay and the silt and the sand in the mason jar. So the size of the particles is a property of the soil. The permeability of the soil. So this is how much water can move through the soil. So sand is the most permeable, silt is the next most permeable, and clay is the least permeable. In fact, clay, it's really hard for water to get into clay. If you look on this diagram to the right, like the infiltration variations show how the water goes through the sand. On the lower right, you can see how a certain amount of water might flow through a thickness of gravel in 2 minutes, where it might take 2 hours to go through that same amount of sand, or 200 days to go through that same amount of silt, or 200 years for it to go through the clay. So basically nothing, like it basically doesn't go through the clay. So permeability is how the water flows through the material. Another property is porosity, and this is the amount of space in the soil sample. So if you look to the right, you can see places there are no pore spaces, so it is non-porous. There might be pore spaces that are not connected, and then the pore spaces could be connected. So it's possible to be porous but non-permeable. In order for it to be permeable, it's got to have a certain amount of porosity. So things that are non-porous are non-permeable. Things can be porous, but not necessarily permeable. But anything that is permeable is definitely porous. So we'll see different soil types tend to have different porosities and permeabilities. Igneous rock is neither porous nor permeable. Same way glacial material is neither porous nor permeable. Quartz sandstone tends to be porous and permeable. When we get to our solid waste unit, we'll see that many landfills are lined with clay. So as we said, clay does not allow water to flow through it. So it's good for lining the bottom of the landfill with clay. And when the landfill is full, then you can put a clay cover on it. Now, this is not necessarily clay, just dirt that's been dug up somewhere. But there are such things as engineered clay, which are really good at keeping water trapped. So we'll see engineered clay liners and landfills both on the bottom and the top. So if you were to go out to a landfill, you could kind of see this, that black material that's on the side, that's the clay liner. And then all this other stuff is getting filled in on top of it. So the tires are really there just to kind of keep it in place. And then a certain amount of soil is put on top of those, and then it's ready for the trash to get in there. Soils that are very sandy increase the risk of groundwater contamination. So when we get to you know, land and water contamination, then we'll talk more about groundwater contamination. But sandy soils, which allow more infiltration, tend to have more groundwater contamination. Other fun properties of soil. Treasure Island, which is located in San Francisco Bay, is vulnerable to earthquakes because earthquakes can cause the soil to become liquefied. So what they're trying to do is stabilize the island by drilling, really drilling holes into the sand and replacing it with, you know, more stronger materials. So adding gravel to the hole, and then it really turns it into a stone column, which increases the strength of the soil. If you're looking for a quick summary here for clay, sand, and loam, so loam is a mixture of clay and sand. So clay has certain properties, sand has its own properties, and then loam combines a lot of these properties, which makes it good for growing things. Consider this next diagram. So if there's water in the soil, in clay, the water will tend to be very shallow and not very much water. But water in sand will tend to go very deep, but not very wide. So loamy soil, which combines clay and sand, the water will go not quite as deep as sand, but deeper than clay. It'll be wider than the sand, but maybe not wider than the clay, maybe a little bit wider than the clay. So we like having this mixture of clay and sand, which we're going to call loam. So those are physical properties of soil. So chemical properties of soil. Soil has what's called a cation exchange capacity. So different soils have different capacities. It can hold nutrients, things like potassium and calcium. So clay, organic material have very high cation exchange capacities. Silt and sand have lower cation exchange capacities. If you check out this chart, different soil types, you'll see things like Montmorillonite is a clay, has a high cation exchange capacity. Based on soil texture, clayey loams have a high cation exchange capacity. Clay has a very high cation exchange capacity. You think that would be good, but then the clay doesn't transmit water very well. So that's why it's good to have a combination of sand and clay. Another chemical property of soil is base saturation. So this is a percentage of bases to acids, where bases tend to be essential for nutrition: calcium, potassium, magnesium, sodium. Acids tend to be detrimental, things like aluminum and hydrogen. So the pH versus the base saturation is another property of soil. So I was mentioning the best agricultural soil is going to be a mixture of silt and sand and clay, which we're going to call loam. And you can even have variations on this. You can have clay soil, loamy soil, sandy soil, clayey loam, silty loam. We're going to look at all those things. The San Francisco Bay Peninsula is a floodplain that has a lot of nutrient-holding clays, and so that tends to be good for agriculture and good for fertility of the soil. Biological properties of soil. If you get fungi or bacteria or protozoans in the soil, that helps with decomposition. Rodents, earthworms, and snails. Slugs, which are detritivores, help break down material and mix the material. And finally, nitrogen-fixing bacteria are good for the nitrogen cycle. There's even a soil food web, right? If you start with the sun, which the plants use to make food, they might die or otherwise create organic matter. Fungi and bacteria and nematodes can feed on that material, which goes to arthropods, which can shred the material. And then there are predators of those arthropods. Certain animals, birds will eat them. Nematodes will eat them. So there's a whole soil food web, that you can barely even see. So one thing we're going to work on is the soil texture chart. So this is a fun triangle. where you're looking at the soil and you're trying to determine the percentage of silt and clay and sand, which tells you what type of soil it is. So you read this going clockwise. So clay starts at 0 on the bottom and then goes diagonally upward to 100. The same thing with silt and the same thing with sand. So we're going to work on this a little bit in class, but there is some practice on this video. So what I want you to do, you can copy this down, but you want to figure out both the percentage of the different materials that are there, and then figure out the texture name. So for the first 3 problems here, there's only one thing missing. So you need to make sure all the numbers add up to 100. For the bottom few, you'll see that there's 2 or more things missing. And so you want to look on the soil triangle and try to figure out what those numbers could be. Now, there's not necessarily right or wrong numbers for the things at the bottom, they're ranges. But what you can do is copy this down, pause the video, work on these, and then come back and check your answers. All right, so let's say you have paused the video, you've worked on these problems, and you're checking your answers. So for the first problem, it has a 10% of sand, which results in it being silt. Second problem, 10% of silt, which results in this being clay. 21% for silt in this one. That is a clayey loam. 27% on the next one is a silty clay loam. 15% of sand in that problem results in a clay. Only 6% of clay in this one, that is a sandy loam. 10% of silt here results in a sandy clay. And then these last problems, you don't have to have these exact percentages, you just have to be close. But a clay loam with 36% sand could have, these percentages of silt and clay. A silty clay might have these percentages, or plus or minus a little bit. Loamy sand is going to be mostly sand with a little bit of silt and clay, and silty loam is mostly silt. All right, well, that is soil properties. Please let me know what questions you have.